want to talk a little bit more about the concept of Future Star and how it got started.
Spike, this is quite an unusual airplane.
Yeah.
How
It's definitely unusual.
how did it come to be like this?
Well, I wanted a plane that I could experiment with rocket power, and that would fit underneath another aircraft. And I didn't want it just to be compatible with, say, Gemini version 2. I wanted it to be compatible with most any aircraft that had conventional tricycle landing gear.
Why do you want to put this airplane underneath another aircraft?
Well, I want to experiment with getting payloads up to really high altitudes, and at least the concept of doing that. And part of that, I think that's really important to the future space industry. And I think it's really important not only to have that technology and for large companies and large nations to be developing it, but I think it's important for people, even kids or people looking at getting into career in aerospace or even as a hobby, to be experimenting with the same things, the same technology, and starting to fly hardware just as a hobby. And I think that's a really neat thing because up till now it's mostly just billionaires and people at NASA that get to play with this kind of stuff and experiment with this kind of stuff out in the desert. It's just the weirdos in Mojave that get to play with it.
Well,
I want everybody to be able to play with this.
Well, it's true. We all have lots of airplanes to play with, but not many of them, not any that I know of, have electric motors and a rocket motor.
Yeah.
And get carried up to a high altitude by another airplane.
Yeah, the combination.
When you do that, where do you go from there?
Yeah, well, first of all, the combination of that makes it a hybrid. So there's some interesting things that happen with hybrid aircraft, and they don't necessarily get worse. So you try to select the kind of the best of the performance envelopes of both aircraft. So to answer your question, once, for instance, a possible mission profile, like I don't really know where this is going, but a potential mission profile would be for Future Star to be carried aloft as far as the mothership could go. It could get air launched or released from the aircraft. And whereas most rocket aircraft have to be in a pretty steep dive, they don't have any extra propulsion besides the rocket motor, and then they have to fire the rocket motor pointed down and then do a high G pull-up maneuver. And they also have the risk of hitting the mothership when they go past its altitude. This concept would be different because it could use, it could immediately level off and climb past the mothership under electric power in a very controlled manner, and even go to a higher altitude with just the electric propulsion before it ever fires the rocket motor. And when it's ready to fire the rocket motor, it could go into a very high power regime in a vertical orientation, so that when the rocket motor is fired, it would be pointed in the right direction, wouldn't be wasting fuel.
Okay. Well, then it's going to go straight up even higher.
Yeah.
And after that, where's it going, and what's it going to do, and what becomes of it after that?
Okay. Yeah. So after the electric power is mostly spent, at least conceptually, it could then fire its rocket motor or multiple rocket motors in stages that are attached to the airplane back here in the tail fairing. And of course that would push it to even higher altitude, potentially an altitude at which there's not a lot of air left. In which case, you would have this aircraft may not actually, Futurestar may not actually exit the atmosphere, but it may not have to, because as we saw in the review episode, it's got this pretty large payload bay hatch here, so the overall layout and design of the aircraft allows it to, this door could be replaced potentially with like a bomb bay door or something like that, or even a rotating door, where another rocket could be housed inside and then be deployed, at which point Futurestar could, still without the problems of re-entering the atmosphere, could put that rocket way up high and then just glide back down to Earth.
Glide back. Futurestar's going to glide back
Yeah,
down to Earth.
yeah. And the rocket would continue up, maybe into suborbital or orbital space.
Are you really going to do that with this airplane?
No, we're not. Not likely. We're not using.
You're my kid.
that
I
type of
worry a little
technology.
bit about some of the things you do.
Yeah. Well, I don't think you have to worry too much. After all, this is basically a park flyer, but I think it's important that it has all the elements of that allow people to experiment with this. We'll call it space access technology. So, they can play with all this stuff without actually having to get permission to go to space, or but it's just a lot of fun. And you were with me when we did the all the flight testing, so
I was.
yeah,
Some of that was very exciting.
yeah, very exciting.
Yeah.
Firing the rocket motor in flight for the first time, that was quite exciting.
Yes, it was.
You remember what happened the first time when we tried?
Well, the first time we tried, nothing happened.
Yeah, I had some.
You had some rocket motors that were older than you were.
Yeah, they were really old. They'd been given to me, and they didn't light. But we kind of had a lot of it figured out. By then, I'd done static, and it was right after that I think we did the static testing, and then did the actual in-flight firing of the rocket motor.
Yeah.
And it went well. We didn't really have any significant problems.
No, we didn't. It
Doing
all
that.
went very
Yeah.
smooth. And I was impressed throughout all that how tough the airplane was.
Yeah,
We had a number of pretty rough returns and landings before we got things sorted out.
yeah. We were
Yeah.
playing with the incidence of the canard and the center of gravity, and we're making some changes to the tail of the aircraft to get it stable. We also had a couple power system failures, which resulted in the airplane, landing in the bushes at high alpha. And I was amazed through the whole flight test program. We didn't really destroy any aircraft or even have any major damage.
No,
I was pretty much expecting that.
we always were able to keep right on flying.
Yeah.
Yeah, the airplane held up amazing.
Yeah. And the rocket motor, when we started firing it in flight, we started with a B motor, I think. It was the same
B.
size, but
That was a little bit of fun.
yeah, it made some smoke and it pushed the airplane. But the C motor, when we went to the C size motor, it really had a lot more thrust. And I think the airframe would withstand even more thrust. But it's it pushes the aircraft vertically.
Yeah.
Even if you were to shut off the motors, it the combination of the motors running and firing the rocket motor was quite exciting. It does tend to pitch the aircraft up a bit, which is pretty good. If you find yourself going past the straight up mark, past 90 degrees, you can just, in fact, the aircraft will kind of naturally wants to do it, but you can roll 180 degrees and continue the flight. Let's talk a minute about the ejection charge, because the rocket motor burns out, and being a model rocket motor, it has an explosive charge at the end.
Another bang.
Yeah,
Yeah.
a pretty decent bang.
A pretty decent bang.
Yeah.
And it ejects the spent rocket motor.
Yeah, yeah,
Yeah.
yeah.
Which
And,
comes falling back to Earth.
yeah, it's on fire when it's leaving the airplane.
On fire,
Yeah,
perhaps. Yeah.
and it's quite of a kick. It's, I guess I'd describe it similar to a kind of a low-powered shotgun shell, maybe when it gets ejected.
Yeah.
And we've done it a couple times at low altitude, and it's ejected it pretty far. What did it throw the spent? How far did it throw the spent rocket motor? Probably
Pretty far.
what, 60, 80 feet, something like
Oh,
that.
more than that.
More than that,
More
laterally.
than that. Oh, 60 yards or more.
Yeah,
Yeah.
yeah. Well, by the time it actually came back down in an arc and
Right.
landed
Yeah.
on the ground, yeah, it was pretty far.
Yeah.
But by the time it's at any reasonable altitude, like more than 100 or 200 feet, it's I don't think the rocket motor's on fire anymore by the time it actually hits the ground. But you definitely want to be careful that you don't do this over an area where there's a fire risk.
Right.
So,
Right.
in fact, for that flight, we picked a day where it had just rained the day before, and we went out the next day to do that testing just because of that.
Right.
And there's not even much to catch fire at our field, but we just wanted
Sure.
to be extra sure that we weren't
Yeah.
catching anything on fire.
That, and after we talked about all that high altitude, we weren't really that high.
Yeah,
We
no,
were
not really.
pretend high.
Yeah, we were
Yeah.
high enough to get some good camera shots, and
Yeah. Yeah.
yeah. And let's talk a little bit too about when we did the release, the first release
Oh, the first release from the Gemini
from Gemini
V2.
V2. Yeah,
That was really the excitement.
yeah.
Um,
I was actually personally, I was more excited about dropping it from another aircraft than I was. I was excited about the rocket motor too, but that was what I really wanted to see out of the project.
well, and a cool part of that, we captured the actual drop on multiple cameras
Yeah, on board the aircraft.
on board the aircraft as well as from the ground.
Yeah,
And you were able to, at that time, you had a second pilot.
yeah. Our friend
Manuel.
Manuel.
Your friend Manuel flew the Future Star while you continued to fly the Gemini.
Right, because he's a way better pilot than I am.
But you were able to form up with him and actually
Yeah.
film the flight and rocket fire of the Future Star from the Gemini up in the air.
Yeah, so we used
It
the
was-
mothership to drop the
Yeah.
aircraft, and then as a filming platform,
Yeah,
a camera ship.
yeah, which gave us
Yeah.
some great video. That was
Yeah.
really, really a fun thing.
Yeah, that
Yeah.
was great.
Yeah.
No, I just remember there was a guy, a friend of ours, who took some video from the ground with a pretty good zoom lens
Yeah.
on his camera, and I really liked the shot where with quite a bit of zoom, the Future Star's just falling away from Gemini.
As smooth as could be.
Yeah,
Yeah.
it looked the releases, all of them were flawless.
Yeah.
Yeah, we didn't ever have a bad release.
No, we-
So,
Yeah, and of course, by the time we did that, we'd already sorted out the airplane.
yeah,
You
we knew
have
we
it-
knew we had a good airplane, and the airplane
Yeah.
flew well.
Yeah.
Yeah. So I think that was only the second flight of this actual airframe, but we got the all the flight testing sorted out with this one behind us.
Yeah, which
Let-
is
Yeah, let's talk a minute about the development of the aircraft, kind of the
Okay.
evolution of the aircraft.
yeah, that was not an easy thing for you.
No,
That-
no, it wasn't easy. We, making this concept work took several iterations of design evolution. I'm gonna grab the first one over here,
Yeah.
and this is what's left of it. I actually removed the wings from it to use on the second one, the number 2, which is
Yeah.
behind us here. But we started out with, you know, as you might be able to see, with a pretty boxy fuselage here, and didn't really know how to do the motor pods, and we had the verticals were parallel to each other, and there was a lot of issues with this. We did get it flying. We had a hard time finding the center of gravity.
Well, we had no idea where it really should be.
Yeah,
So-
true. And we couldn't find any resources, you know, online or anywhere else that would indicate where, you know, there's for canards there's center of gravity calculator online, a web tool that can help you find the center of gravity. But this is not just a canard; it's a lifting body as well.
Well,
So-
and this used 2 identical wings. as
Yeah,
I
most
recall.
canards like the final version used a smaller forward wing, and this version actually used 2 of the same size wings. So, yeah, we had a hard time. We also had a hard time getting the thrust angle right, and I think we threw this and broke it. We threw it, went a few feet and broke it like what 5 times or
Like
something like that.
Half a dozen times.
Yeah, before we actually got it in sustained flight.
Yeah.
And we kept I don't know if you can see, but we just kept taping and gluing the poor fuselage back together. The nose would just be in 50 pieces, and we'd glue it back together, and we just kept trying different things until we got it. And at the end of that day,
We did this all in one day.
yeah,
And at the end of the day, we had a beautiful flight.
we had one good flight.
In between, we made a trip to the hardware store and we bought all the super glue.
Yeah, yeah, that was pretty funny. Yeah, so we had to glue this thing back together a lot, and I actually decided not to fly this again, even though, you know, I wanted to fly it some more after that first flight. But I wanted to fly it again, but it was so delicate, and it was so glued back together by that time. I decided to build another one just like it, but more robust, to do some more testing with. And from all that crashing, the wings were not damaged. So I took the wings off of this and used them and built a more robust fuselage with pretty much the same design. And that's this aircraft here. And you know, we're already thinking about the payload bay and the tricycle landing gear. We've since borrowed some more parts off of this, but you know, we had a really large payload bay, and we kind of hadn't figured out exactly how the geometry of everything should be. But we flew this one quite a bit.
We did.
Yeah, and we never crashed it, but it also didn't have hardly any performance.
It
Right.
got a bit heavy. I
Yeah,
believe, in the
yeah.
building.
The more
Yeah.
robust fuselage was
Yeah.
too heavy, and it had a lot of drag, and honestly, it didn't handle that well.
Mhm.
And you know, at this time we still were using forward elevons on the canard for the only control surfaces. And we later, for the third version behind me here, we switched those to the rear wing. And so this aircraft flew, but it was a dog. Honestly, it was. We would not have wanted to release this design to anybody. It was not ready. It was a cool novelty, but
Yeah.
it wasn't anything that anybody else would really want to repeat. And we actually, I prepared everything, the release mechanism and everything, to air launch this, and we never did,
Right.
because there wasn't really a lot of point in it, because it didn't fly that well. You know, we could have added more power to make it fly, but I really wanted, we had small motors on it, but I really wanted an airplane that that inherently had good performance, not just one that was a poor performer and then had power added. So I think the big part of the design evolution came when I was looking to reduce drag for the airframe. And I thought, well, I want that large surface area on the bottom of the airplane, but I don't really want the big cross section of the fuselage. So I thought, well, what would happen if I'd angled the sides of the fuselage in, you know? And I'd already, we'd also had a center of gravity problem, right?
We did.
Yeah, we were having to add like kind of an insane amount of weight to the nose.
We had to add nose weight, which
Yeah.
I don't like to do.
Which
Yeah.
I don't want to release a design that's inherently, you know, tail heavy and needs a whole bunch of nose weight added. That's just not a good thing. And
I think you taped about $3 and change up in the nose of that thing. But did you ever
Yeah,
give
reusing
that back
coins.
to me? That $3?
no, I'll have to send it to you through PayPal or something. Thanks for reminding me. But so that what that did, it gave us a smaller cross section for the fuselage. But I also kind of had a problem of what I was going to do with the verticals. So I decided to angle them out a bit, and of course that changes the thrust angle. So we had to do a little more experimentation to find the right thrust angle again. So we kind of had to go backwards a bit in the design phase. Another thing we did, you know, drastically different. I decided that you know, bringing the rear part of the fuselage to, you know, to a complete taper was just impractical, you know, to fit the aircraft into a length and a configuration that you want down, Kujimo? Yeah. This is our production assistant here. He's a good doggy. So you know, I figured that I would make the tail fairing, I would reduce the size, and at some point we would just chop it off. There's a kind of unique thing that happens with drag with a fairing like this. If you manage to get the size down to less than half of the cross section, there's beyond that, there's really not a lot of point in bringing it to a taper on a trailing surface. So
That was figured out by a German fellow by the name of Cam
right,
back perhaps in the 30s. I don't
Yeah.
remember exactly.
yeah. So that's the
It's
concept behind this
It's
fairing.
known as the Cam effect.
Right.
Yeah.
Yeah. Yeah. So the changes there were the tail fairing angling the verticals out, so they're at 45 degrees each to center, 90 degrees to each other. They're also happen to be at 90 degrees to the sides of the fuselage, so that keeps the aircraft easy to build
Well, Spike,
because they're at a right angle.
that's the thing. By this time, the aircraft looks rather complex and complicated in the shapes and angles.
Right. It looks that way, but yeah, it's actually not that complex. It's all flat. It's all basically flat pieces glued together. So you can build the aircraft on flat surfaces, and then just glue a few of the major pieces together and throw some covering on it. We wanted to keep an eye on the structure for this one, so we covered it with clear like we do with a lot of our prototypes.
Yeah.
And I was also kind of worried about the ejection charge breaking the firewall for the rocket motor, and we added this compression strut, which actually ended up as part of the final design, that goes forward and brings that shock load from the firewall up to the main wing spar. So that keeps the rear end of the aircraft from just being blown apart by the ejection charge when it comes out. And we retained the tricycle landing gear, and we also retained this large payload bay here. And the change in design actually made it the interior of the plane more accessible. So, and also, I'd had a different nose on this airplane, but we decided I looked geometrically. I was able to rearrange the shape of the nose to get the battery just a little bit farther forward. And I think we changed the shape of the canard on this too before. So you know, it was originally different, and we retrofitted it with a different canard.
You tried at least a couple different canard configurations.
Yeah. So, and we experimented too. We flew it without the without the fins on the tip.
The winglets.
Yeah, and we experimented with the size of the main vertical stabs.
Mm-hmm.
But this is pretty much what we ended up with, and we just reproduced it here and made sure that we could. We simplified the construction a little bit.
You've actually made it easy to build.
And we've actually made it very easy to build. So you get about a weekend, you could build the structure, and probably another weekend you could, if you have some level of experience building basically anything out of wood, you can put some covering on it and put your electronics in it. So that's a little bit of the history of the design evolution of the aircraft. And we're using a piece of carbon fiber crossweave tubing for the motor slot here. So what that does, that can hold quite a bit of pressure. It doesn't split like a piece of pultruded carbon fiber would just shatter. It also allows it to be glued to the firewall. So it's important that glue joint be pretty good so it doesn't break out and eject the carbon and blow apart the tail fairing as well. So we didn't really experience any failures with the rocket motors though.
No, we've had.
So if you follow the plans, it should work pretty well.
Yeah.
Yeah.
Well, and I know you're proud of the airplane, the way that it in flight, if it gets out of shape or is left at any angle, it will recover on its own to a more or less straight and level flight.
Yeah.
Yeah.
Yeah, it's actually in pitch and roll, it's extremely stable, way more than it would look. That's in roll. It's partly to do with the wing sweep, but there's also some dihedral in the rear wing, and the dihedral effect from the angled fins as well. And the stability in pitch is actually very good. The speed gets regulated very quickly, the airspeed. So we did a lot of testing with it, putting it in extreme angles of attack at extreme speeds and making sure it will self-recover almost immediately. So I've done everything I could do, in flight to break the aircraft, and we really weren't able to in flight. So that's been good. We did a little experimenting with the angle of the landing gear too, which also helped take off. And we've got it now to where between the little bit of angle of the fuselage up and the angle of the canard, where it'll take off from the runway just by itself in pretty short distance. So no problem there. And what do you see people doing with this in the future?
No telling.
Yeah.
No telling. I know you're hoping other people will pick it up from here and do more exciting things with it.
Yeah. Yeah, if you do feel like doing other experiments with it, I would recommend first building it, per the plans, flying it like that before you change things too much. But then, after you do that, I definitely want to see what changes are made. There's some of these things were a bit of a delicate balance, but overall, in the end configuration, does allow quite a bit of flexibility for change.
Spec, it's a little airplane,
Yeah,
and it's unlike many. It's not a conventional airplane by
not
any
at
means.
all. Yeah.
What does it glide like? What would you say about a glide
It,
path?
it does not glide very good.
That's
It glides very poorly. So with complete power off, it is possible. We did this in testing. It is possible to bring it in at quite a bit of an angle and build up enough kinetic energy to flare, and make a decent landing. But I would really, it actually, ironically, as inefficient as it is in glide, it's actually, once you start applying a little bit of power, it actually doesn't take much power to keep it up and maneuver it around, throw it around the sky. So as far as power consumption, it's fairly efficient. But as far as glide path, it's very bad. And part of that is because it's so lightweight as well. So I would definitely recommend landing the airplane while it still has battery power left. So we had a few instances with power failure, like we talked about earlier, where
yeah,
I think Manuel was flying it when one of the motors on this one came loose.
yeah, yeah.
The set screw came loose that holds the motor in, and one of the motors failed. He was able to, even with one motor, he was able to keep under control.
He did.
And yeah,
He did keep it under control, and
it landed without damaging it.
he landed without damaging it. He
Yeah.
didn't quite get back to the runway,
Right,
but
right.
when we saw what had happened, it was surprising he was able to fly it at all.
Yeah,
Yeah,
yeah. With one motor out.
yeah,
But the motors are angled in a bit, so I'm not too surprised.
yeah.
You know, I kind of wanted to do some actual flight testing where I could shut off a motor,
Mhm.
but I really don't think that's
Yeah.
not really worth it. We'll you know, some failures will happen, and you know, like that. We did get to kind of get an indication of what it'd be like anyway, but yeah, it was just a lot of fun. And now we've added FPV camera here, and a video transmitter, and a power filter and regulator for the camera. So we're looking forward to playing with it some more and doing some more flights. Maybe air launch it from a bit higher altitude and guide it back with FPV. Maybe even fire the rocket motor in flight with FPV. So we'll see.
Yeah.
See if we can recruit Manuel again to fly it for us
Yeah.
when he has time. So that'll be great. Also, should probably talk a little bit aerobatics. Those of you guys that like to do aerobatics with park flyers, it is aerobatic, but it doesn't like to. You know, it wants to be stable. It's actually a very stable aircraft. So, you know, if you try to bank it more than about 30 degrees, you'll notice it's kind of got a hard point there. It doesn't want to go past that. Yeah, you can override it a bit and push it past that. And once you push it there, you can fly around inverted. You can, you know, do all sorts of maneuvers. There's no rudders or yaw control. So there's, you know, things like knife edge flying you're not going to be doing with it. With these motors, these are the Park 370 E-flite motors. It will do loops just great. There's no prop wash going over the control surfaces, so you want to keep a little bit of speed, but it actually has good control down at very low speeds. And if you throw the stick over to the side to roll it, the rate of roll is actually pretty insane. And
it goes straight.
yeah, it
While it's
goes.
rolling.
Does a
Yeah.
pretty axial roll,
Yeah.
and it's a lot of fun. But it's definitely doesn't fly, you know, a true track for like pattern style aerobatics. It's definitely not that kind of aircraft. So, but it can do a lot of really neat aerobatic maneuvers.
Yeah.
You know, for an airplane that only has two control surfaces. But I'm pretty happy with just those control surfaces.
Yeah.
For the purposes of experimenting with rocket motor, air launch, and doing all this stuff. Manuel was able to fly it quite accurately and precisely when we did the formation flying.
Yeah, yeah, he did.
And it's no problem to bring it to a very specific point for landing.
He landed right in front of us every time.
Yeah, yeah.
Yeah.
Well, except when the motor failed.
Except when
Yeah.
the motor failed.
Yeah, but
Yeah.
and I flew the aircraft quite a bit during initial flight testing. It wasn't till we wanted to do the air launch where we started checking him out with the aircraft. But anyway, it's been a lot of fun, and it's been there's been some definite challenges in getting everything to work because the design parameters, it had to fit underneath the other aircraft, and it had to, there's a lot of things I couldn't change about the plane that would have been easy to change, but that we couldn't. So we had to find kind of more creative ways other things to change to make it still do its job. So anyway, we hope that you weren't bored by our long-winded conversation here, and we hope you have a lot of fun with it. And send us pictures and links to your video if you put a video up on YouTube of your airplane, and let us know what you've done with it. Yeah.
Don't put it in orbit.
No, bad. Don't
No.
put it in orbit. Not yet.
Yeah.
Yeah, if you do ask for permission or go to international waters and get a barge. But anyway, okay. Well, Paul, I want to thank you as well for being in there and believing in me all the way through this project, even when everybody at the field said that it wouldn't work.
Everybody at the field said it wouldn't fly.
That it wouldn't fly, or
Yeah.
it wouldn't be controllable.
Yeah.
And,
Well,
we eventually got through that part.
it's entertaining.
It's been
Yes,
very
yes.
entertaining.
Yeah.
And we want to thank all of you for also everybody who's bought the Gemini V2 plans. That's basically made this possible, and some other cool things that we're working on that we can't really talk about quite yet, but you'll hopefully see very soon. Not quite in this direction, but anyway, you'll see.
Your dog went to sleep already.
Yeah, Kujima's
Yeah.
asleep.
Yeah.
He's a lightweight.
Yeah.
Okay, everybody. Everybody, you have a good one, and thanks for watching. Don't forget to subscribe. Leave us your comments here, what you thought, and we'll see you next time.